We're going to start this section by reviewing some information about lines. So when we talk about the slope of the line, we're talking about steepness. Slope, remember, is the difference in the y values over the difference in the x values, and we're commonly referring to that as the rise over the run. So if we were to take ordered pairs and label them x1, y1, and x2, y2, then the slope is going to be the difference in the y's over the difference in the x's. And we could write it as y2 minus y1 over x2 minus x1. Remember, it doesn't matter whether we switch which point we call the first point and which one we call the second point. Slope is also called an average rate of change. So those words are actually used interchangeably in mathematics. When we talk about the slope of a vertical line, that slope is going to be undefined. So remember, a vertical line is going to look something like this. It's going to be straight up and down. And it's always going to be in the form of x equals some kind of number. When we talk about a horizontal line, now we're talking about something that looks like this. And a horizontal line will always have a slope of 0. Horizontal lines are always in the form y equals some number. So, if we're looking at a line, we can pick any 2 points on that line and we can find the slope of that line. So that average rate of change is always going to be constant. It's going to be the same. So we're going to see that average rate of change being the same whether I'm looking at 2 points maybe in here or whether I'm looking at 2 points up in here. If that slope is positive, the line's increasing, so this guy would be an increasing line. But if it's negative, then it's going to be a decreasing line. Let's talk a little bit more about the meaning of slope. Slope is always going to be the average rate of change, and it's always the average rate of change of y with respect to x. So as x increasing or decreases by some units, then we can say that y increases or decreases by some units. So let's kind of put that in perspective. Suppose we have a slope that is 1/2. Okay, so remember, slope is the change in y over the change in x. So what this means is for every 2-unit increase in x, remember x is what's going on in the bottom, then there's going to be a 1-unit increase in y. And we're getting those values from that slope. That denominator tells us what's going on with x. That numerator tells us what's going on with y. Now, because this is a positive number, then this means we're increasing along x and along y. We can also view this a little bit differently. We could view this as a 1/2 divided by 1. And we could think about x, that denominator, as your 1. So for every 1 unit increase in x, then that difference in y ends up being a positive 1/2. So we have a 1/2 unit increase in y. So we can think about it in a couple of different ways. Both statements would be accurate to describe the slope for that particular example. So let's talk a little bit more about finding the equation of a line. When we find the equation of a line, if we have a slope and a point, then we can use this point slope form. So we're going to plug that point in here. That's your x1, y1. And then we're going to substitute the slope in here. Now, usually we want this in slope intercept form, and that's just because it's a nice way to write that equation. You can easily identify the slope and the y-intercept, which are 2 key elements for a line. So slope intercept form solves for y, gets y by itself, so it's y equals mx plus b. M is always going to be the slope. That b is always going to be the y-intercept. General form is ax plus by is equal to c. So notice that we've got the variables on the left-hand side. Everything has to be a real number, so we're not talking about imaginary or complex numbers yet. And we want a and b to not be 0. Some textbooks will put stipulations on this and say no fractions. And then a horizontal line, we talked about this a little bit ago, is always going to be in the form where y is equal to b. So an example would be like y equals 3. Notice it's going to cross that y-axis at that value of 3. So that number, whatever it is, will always be a y-intercept. So then we could write it that way for this example. For that generic y equals b, it would be 0b. Vertical lines, let's say we're looking at x equals 2. It's always in the form of x equals something. A is going to be the x-intercept. So notice that at x equals 2, this guy does cross that axis at 2. That y-coordinate is going to be 0. So generically, for x equals a, we could call that the point A0. So we could take lines and we can graph them, and we're always going to use that slope-intercept form. It just makes it easier to graph. We're going to start by plotting that y-intercept, and then we're going to use that slope to find another point, and then we're going to connect those dots. So let's look at an example. Let's say we have y equals 1/2 x plus 1. So we always want to identify the slope and the y-intercept. So in this case, that slope is 1/2. The y-intercept, that's your b, and in this case it's 1. So you always start with that y-intercept, and then from the y-intercept you want to find another point. This tells us how we're going to move. So we're going to move up 1, and then we're going to move right 2. You have to do both movements in order to get another point. So from this point, we're going to move up 1 and then right 2. There's our point. Connect the dots, and there we are. Let's do another one. Suppose we had y equals -2/3 x plus 3. Our slope would be -2/3. Y-intercept is 3. So if we wanted to graph, we would start with the y-intercept of 3. And then that slope will give us a way to find the next point. I'm going to keep the negative with the top. You can put it with the top or the bottom. You cannot put it with both. So I'm going to go down 2, and then I'm going to move right 3. So from here, if I go down 2 and then right 3, there's my point on the graph. And then we can just connect those dots. Now, if we're not in slope-intercept form, then we could take the equation and solve it for y and then use this method. Or we could just find 2 other points that's on that line. Let's look at an example. Suppose we had the line 2x plus 3y is equal to 6. We could solve it for y. Or let's say we want to find x-intercepts. That would be a great way to solve this. Let's find both of the intercepts. To find an x-intercept, we're going to set y equal to 0, and then we're going to solve it. So if we plug 0 in for that y, we're going to have 2x is equal to 6, so x is equal to 3. So our point is 3, 0. Now let's find the y-intercept. To find the y-intercept, we're going to set x equal to 0. So if we plug 0 in for that x, we have 3y is equal to 6, so y is equal to 2. So our point is 0, 2. That gives you enough information to graph. So we have an x-intercept at 3, a y-intercept at 2, and we can connect those dots. And there's our line. So now we want to move on to finding equations of lines. So let's look at a few of those examples. Let's look at number 32. We have a slope of 2 and a point of negative 2, 3. And we want to find the equation of the line. So we know the slope is 2 and the point is negative 2, 3. This is where we're going to use that point slope formula. So we're going to substitute in everything we know. This is our x1 and our y1. So if we substitute in, y1 is 3, slope is 2, x1 is a negative 2. Now I'm going to clean this up. And I'm going to put this in slope-intercept form. So slope-intercept form means I need to solve this equation for y. If we add 3 to both sides, there's our slope-intercept form. Now let's say we want that general form, just for fun. General form gets x and y on the same side, and we are going to eliminate fractions if we have any. So to get x and y on the same side, we need to move that x to the other side. And we can do that by subtracting 2x. So we have the x and the y on the same side. That's 7. That number is by itself on the other side. So there's our general form. Let's do another one. Let's look at 33. So 33 gives us a slope of negative 3 over 2. And then our point is 2, negative 4. We're going to use that point slope equation. Let's substitute in what we know. Our y1 is a negative 4. Slope is negative 3 over 2. x1 is 2. Clean it up. Minus negative 4 would be a positive 4. And I'm going to distribute that negative 3 halves. Now let's do slope-intercept form on this one too. So we're going to move that 4 to the other side by subtracting. So this is slope-intercept form. Now, let's say we want general form also. General form has to get x and y on the same side. So let's move this x term to the other side. And we can do that by adding it. So we're almost there. We want to get rid of fractions. And we can do that in this case by multiplying everything by 2. So if we take 2 times that 3 halves x, we're going to have 3x. 2 times 1y is 2y. And 2 times a negative 1 is a negative 2. So there's our general form. So in both of those examples, we had a slope and we have a point. Suppose we don't have that. Suppose we have 2 points. We have the point 1, 3 and the point negative 1, 2. To find the equation of a line, you have to have a slope and a point. Well, we have 2 points, which means we can find the slope. So I'll substitute in everything we know. I'm going to label this as x1, y1, and this is x2, y2. It doesn't matter which one you pick for the first and the second point. I just chose the first point for the first point. So we have y2 minus y1 over x2 minus x1. So we're going to have a negative 1 in the top, negative 2 in the bottom. Negative divided by negative is a positive. So there's our slope. Now let's find the equation of the line. And we're just going to go for slope-intercept form here. So we're going to substitute in everything we know. And I'm going to substitute in that first point. I'm going to distribute the 1/2. And then let's add 3. And 3 minus 1/2 is going to be 5/2. So the next few examples are looking at some special cases. In 57, we know we have a horizontal line, and we know we want to go through the point -3, 2. So if it's horizontal, and it's going through the point to -3, 2, let's draw a picture of what this guy's going to look like. Here's the point -3, 2. Horizontal means it has to look like this. So to go through this point, we know this has to have a slope of 0. Horizontal lines always have a slope of 0. So this is going to be the line y equals 2. Notice that y-intercept there is crossing that 2. So there's our line. Let's look at 56. We'll come back to 54. So 56, they're telling us the slope is undefined. That means this is going to be a vertical line. So that means it's got to be in the form x equals a number. Just like the last one was horizontal, it had to be in the form y equals a number. Notice that it was that y value. Same thing is going to be true here. Let's draw a picture just so you can see what's going on. We're going through the point 3, 8. If we're going to be vertical, it's going to have to look like this. It's got to be x equals something. Well, our x value is going to have to be equal to 3. Okay, that's the only x value we have. And then 58. We want a vertical line containing that point. Vertical means it has to be x equals something. If we're going through the point 4, -5, and we want to be vertical, then it's going to have to look something like that. So what would that x value have to be? Well, in this case, it would have to be equal to 4. So we've got the line x equals 4. Now let's go back to number 54. In 54, they're giving us an x-intercept and they're giving us a y-intercept. Now, if we have an x-intercept at -4, we know it's crossing the x-axis at -4. We also know that y value has to be 0. So we can rewrite that as an ordered pair. Y-intercept, same kind of thing. We know the y-intercept is 4, so we know that y value is 4. Because it's a y-intercept, that x value has to be 0. So now this is going to be really similar to number 49 because we have 2 points. So let's work through this one. We had an x-intercept at -4, 0, and a y-intercept at 0, 4. This is our x1, y1, x2, y2. So it's going to be y2 minus y1 over x2 minus x1. So we're going to get a slope of 1. So we know our slope is 1. Now we also know that y-intercept, and remember that's going to be our b value. So we could go ahead and cut to the chase here because now we know the slope. We also know the y-intercept. So let's substitute in everything we know. Slope is 1. The y-intercept was 4. So there's our line. If we wanted to, 1 times x is just the same thing as x. Let's look at a few other things since we're diving into lines. When we talk about parallel lines, we are talking about lines that are never going to cross each other. So the way that we know they're parallel has to do with their slopes. Their slopes are always going to be the same, and that would allow them to not cross. If we're talking about perpendicular lines, we're talking about slopes that are crossing at right angles. So we could have a line that looks like this, and then we could have one that looks like that. So you can see that right angle coming out here. The relationship between the slopes here is interesting because they're going to be negative reciprocals of each other. So what that means is one will be positive, one will be negative, and the fractions are flipped. So I want to play with these ideas, and I want to move down to 103. Let's look at the slopes of these lines. So if we look at that first one, the slope of that line is 2. The slope of the second line is 2. So since the slopes are the same, then they are parallel lines. So if we were to graph these, we would see that they're never going to cross each other. Now I encourage you to graph these in your calculator or in Desmos. Let's look at 104. In 104, what is the slope of that line? The first one has a slope of 1/2. The second one has a slope of -2. So one way to tell if they're perpendicular is we can multiply them together. So if we multiply those slopes together, we get a -1. And that means that they are perpendicular. Now, they are also negative reciprocals of each other. This just checks to make sure they're negative reciprocals. But let's say we start with that 1/2. If we were to change the sign and flip the fraction, if we change the sign, it would be negative. And if we flip that fraction, it would be a 2/1. So if we start here and we do change flip, we get that. That's the negative reciprocal of that 1/2, which means that these guys are going to be perpendicular. There's two ways to think about that one. Now, if we look at this one, the slope of the first line is 4. The second one is -4. So they're not the same, so we know they are not parallel. Now, they're also not negative reciprocals of each other. Let's try that multiplication method like we did on the last one. If we multiply those together, we get -16, and that's not -1. So they are not perpendicular. If they're not parallel and they're not perpendicular, then these guys are neither. Now, let's look at a few more examples where we're finding the equation of a line that's parallel or perpendicular to something. Let's look at number 1. We have perpendicular. We want to be perpendicular to the line 2x plus y is equal to 2, and we want to contain the point -3, 1. So this gives us an x1 and a y1. We also need a slope. So let's find the slope. To find the slope, we're going to move that 2x to the other side. We want to get y by itself so it's in slope-intercept form. So if we look at this guy, our slope is -2. Now remember, we want to be perpendicular. So let's find that perpendicular slope. Perpendicular slopes are negative reciprocals. So we want to change the sign and flip the fraction. So we're going to change that sign. So now we need a positive. And if we flip the number 2, remember 2 is really 2/1, we're going to have a slope of 1/2. So that's the slope we're going to use for this problem. So let's look at that. Substitute in everything you know. And I'm going to find the slope-intercept form again. So I'm going to distribute that -3. And then let's add 1 to both sides. So there's our line. Oh, just kidding. Let's go back. Sorry, I used the wrong number. Our slope is 1/2. So y minus 1, that's our y1, equals 1/2 times x minus -3. Our x1 is a -3 and our slope is a 1/2. I'm going to clean this up. That's x plus 3. I'm going to distribute the 1/2. And then I'm going to add the 1. So there's our line. Now, let's graph these in Desmos so you can see what they look like. So there's our first line. Y equals -2x plus 2. And the one we just found is that one. And we said we wanted to go through the point -3, 2. So I'm going to plot that too, so you can see it. So if we look at the graph, that first graph, that black one, is the original line. Now remember, we wanted to be perpendicular to this line, going through the point -3, 1. So here's our point -3, 1. So the line we came up with was y equals 1/2 x plus 5/2. So you can see how that red line is perpendicular to that black one. You can see the right angles coming out. You can also see how it's going through that point -3, 1 that we wanted to go through. So that's a good way to verify your answers on these. Just graph it and make sure everything works. Now let's look at 2. 2 says we want to be perpendicular to the line y equals 8. And we want to contain the point 3, 4. There's not a lot we're going to have to do on this one. Let's draw a picture of what we have. And this one's a perpendicular also. We're looking at the point 3, 4. So here's our point. We want to be perpendicular to y equals 8. Y equals 8 is a horizontal line, so it's going to look like this. Well, if I want to be perpendicular to this guy, the only way I can be perpendicular is if I have a vertical line. Vertical lines and horizontal lines are perpendicular to each other. So now I just need to name that line. I know I have to go through this point. It's got an x coordinate of 3. So it's going to be x equals 3 for that line. Let's look at number 3. Number 3, we're looking at the line x minus 2y is equal to -5. We're going to contain the point 4, -5, and we are going to be parallel. We need to have a slope. So to find the slope, we need to solve this equation for y. So let's do some fancy math. Let's move that x to the other side. And then let's divide everything by -2. And make sure you divide all three pieces here. So this is understood -1. -1 divided by -2 is a positive 1/2. -5 divided by -2 is going to be a positive 5/2. So we know our slope is 1/2. We want parallel. Remember, parallel lines have the same slope. So we're going to use a 1/2 for that. Now we have enough information to substitute into our formula. So we have y minus y1 equals m x minus x1. I'm going to clean this up. Distribute the 1/2. And then I'm going to move this guy to the other side. So there's the equation of our line. And a good thing to do would be to graph this in Desmos so you can see what it looks like. So let's do that. So the line they gave us, and I'm just going to use the one that was on our notes. X minus 2y is equal to -5. So Desmos does not have to have the equations off for y. We want to go through the point 4, -5. And we ended up with the line y equals 1/2 x minus 7. So you can see how it's meeting that criteria. That black line is parallel to that green line. We wanted parallel lines. We wanted to go through that point of 4 and -5, and we are going through that point. And then let's look at that last example. In that last example, we want to be parallel to the line y equals 5, and we want to contain the point 4, 2. Parallel lines, we're looking at y equals 5 through the point 4, 2. So let's graph what we have. Here's the line y equals 5. We want to go through 4, 2. If I want to be parallel to this line through this point, it would have to look like this. That's my only option. Which means I now have another horizontal line. And that horizontal line's going through that point of 2 here. So it's going to be the line y equals 2.